All right, another exciting stoichiometry question with a titration. In this particular question, what it does is it asks you to calculate a molarity of a sulfuric acid solution, but instead of giving you the molarity of the titrant, it's combining this question with calculate the molarity of the titrant as well. And so what we want to do is we want to there's multiple ways to attack this problem, but my suggestion would be to just go ahead, calculate the molarity of the solution, because that's kind of how we're familiar with working with it. So the first thing I want to do is go ahead and figure out the molarity of the sodium hydroxide solution. And so that would be the number of moles of the sodium hydroxide divided by liters of the sodium hydroxide solution. And I can directly put down the liters because it said that I had 250 milliliters, and so that's 0.2500 liters of solution. Now, what I have to do is figure out the number of moles of sodium hydroxide, and I'm just going to use the molar mass and the mass that's given because that's how I convert to moles. So this is very straightforward, from previous examples from converting grams to moles. I think the molar mass is 39.997 moles. And so I get 0.8001 mole of sodium hydroxide. And so I can take this and go ahead and put it here in the numerator and do the calculation. 0.8001 mole of sodium hydroxide divided by the 0.2500, and I get 3.200 molar sodium hydroxide. And so now what I've done is I've taken this information and I've turned it into a molarity of the titrant. So now the question is essentially saying, I titrated 25 milliliters of sulfuric acid with 3.200 molar sodium hydroxide, and it took 16 milliliters of that solution to reach the endpoint of the titration. What's the molarity of the sulfuric acid? And so I'm at this point, can sort of remind myself of everything that I'm given. I'm given the 25.00 milliliters of the sulfuric acid. I'm given, and I had to calculate this, but I'm still given it, the molarity of the sodium hydroxide solution, and I'm given the volume of the sodium hydroxide solution that it took to do the titration. Okay, and I'm asked to calculate the molarity of the H2SO4. And so we know that the molarity of the H2SO4 is liters of H2SO4 solution. Divide in the denominator, and moles of H2SO4 in the numerator. Now, the problem gives us the volume of the H2SO4 solution, so that's what we're going to use that bit of information for. So I'm going to use that as the denominator of the ratio in order to calculate the molarity of H2SO4. Now I did convert it to liters. Now I need to figure out the moles of H2SO4, and I'm going to do that with a stoichiometric analysis using the information that's left. But in order to do that, I'm going to need a balanced chemical equation. So it's sodium hydroxide reacting with H2SO4, it's going to produce water, and it looks like sodium sulfate. I'm going to need 2 here and 2 here to balance the equation. And now I have the information I need to produce the rest of my plan. Okay, so I'm going to, so I don't need to worry about this number in my plan because I've already got something that I'm going to do with it. So I don't start plans with per expressions. And so that leaves me with the 16 milliliters of sodium hydroxide solution, and that's where I'm going to start. So I'm going to start with milliliters of sodium hydroxide solution, and I'm going to ultimately calculate the thing that I need, and the thing that I need is the number of moles of H2SO4. So mole of H2SO4. So I'm going to go from milliliters of sodium hydroxide solution. I need to convert that to liters of solution. Then I can use the molarity to convert that to moles of sodium hydroxide. And then once I have moles of sodium hydroxide, I can use the balanced chemical equation to convert that to moles of H2SO4. And so that's my full plan. And so let me go ahead and start with the 16.00 milliliters of sodium hydroxide solution. I'll convert that to liters. 1 milliliter is 10 to the minus 3 liters. And then I used the molarity is 3.200 mole sodium hydroxide per liter of solution. And I calculated that in the first step earlier in the problem. And I know that 2 moles of sodium hydroxide are required for every 1 mole of H2SO4. And that calculating that gets me 0.02560 mole of H2SO4. And now I have this ratio already set up for me. See if I can move it down over here. Looks like it's going to be too difficult to move. So here what I'll do is I'll copy it, paste it. And so I have 0.02560 mole of H2SO4 divided by 0.02500 liters of solution, and I get 1.024 molar H2SO4. And that, my friends, is the final answer.